Okay, hi everybody. So what is the divergence test? So we're going to add up infinitely many terms. We'll call each term c sub n, and we'll sum maybe from n equals 1 to infinity, maybe from n equals 0 to infinity, really over the natural numbers. And so to sort of hide this detail, sometimes I just like to say the sum over n of these terms. Okay, now, if the c sub n do not themselves go to 0, then, quote, the divergence test, this is what people call this, the divergence test says that this infinite sum of those terms, which don't go to 0, if they don't go to 0, then this sum does not exist. What does that mean for this symbol to not exist? Well, it means that the sequence of partial sums does not converge. So, yeah, that's what the divergence test says. Okay, now, part B. For various fixed values of x, a real number, explain what the divergence test can tell us, if it can tell us anything at all, about this particular sum. We're summing over the n, and we're fixing some value of x, which will be an exponent. Okay, so part B. Well, if x equals 1, then, okay, sum of the n to the x, then c sub n equals n to the x equals n to the 1 is just n. So the terms we're summing are just n. Well, n clearly does not go to 0. Okay, so divergence test implies the sum of n to the x, which in this case for x equals 1, does not exist. Another way to say does not exist, you could say diverges. Okay. Let's try something else out. So what we're supposed to do for various fixed values of x. So let's just pick some more until we can get a complete picture. In the end, what will be the case is that whenever x is greater than or equal to 0, this sum will diverge and not exist. When x is negative, we don't know. This will be our final answer. But let's discover it. Okay, so let's try something else. If x equals 2, then the c sub n's are n to the 2, or n squared. And n squared just keeps getting bigger and bigger. It, in particular, does not go to 0 as n gets bigger and bigger. And that implies that the sum of n squareds does not exist. Okay, let's try x equals 1/2. Then c sub n is n to the x, which is just another way of saying squiggly line n. But that does not go to 0. This does not converge to 0 when n gets bigger. And so right away we have the divergence test saying that this sum does not exist. Does not exist. Or we could say it diverges. Let's try if x equals 0, then c to the n equals n to the 0 is just 1 always. Well, the sequence 1, 1, 1, 1, 1, 1, 1, 1, 1 does not go to 0, and so does not exist. The sum of 1 over n equals 1 to infinity, or 0 to infinity, or something, whatever. If, however, x equals negative 1/2, then c to the n equals n to the negative 1/2, which is another way of saying 1 divided by squiggly line n. And that actually goes to 0. As n gets bigger and bigger, this gets bigger. 1 divided by a bigger number gets smaller, and the whole thing goes to 0, which implies that that divergence test does not know. The divergence test cannot tell us anything. We don't know. The sum of 1 over the square root of n over from n equals, I don't know, maybe 1 to infinity, may exist, or it may not exist. We just do not know, at least according to the divergence test. Now, if x equals -1, the c sub n is n to the -1, which is 1 over n, and so this is the harmonic sequence. That does go to 0. We proved that. And so what does this mean? Well, the divergence test does not know. And so the sum over 1n, it may exist. It may exist. It may not exist. We're just not sure. Okay, so basically, let's summarize what we have learned. Over here, if x is greater than or equal to 0, x is obviously a real number, then divergence test says the sum of n to the x diverges. It does not exist. Okay? We can actually conclude something. We conclude that it does not exist. Over here, though, if x is a negative number, x is a real number but negative, then the sum of n to the x may exist. It may not exist. In particular, I'll spoil it for you. When x equals -2, the sum of n to the -2 is the sum of 1 over n squared, is actually pi squared over 6, sort of that amazing formula. When x equals -4, the sum of n to the -4 equals some. I think somebody might have figured out what this is, actually, but maybe not. Actually, and some of these, I think, to the 3 maybe is. Some of these are not known what the value is, but actually it'll converge. And actually, when x is negative, so here we're seeing that it will exist, that these sums will converge. But when x is -1, the sum of 1 over n, we'll actually later show this, it diverges. Okay? But the divergence test couldn't tell us any of that. All it could say is it may exist or it may not exist. I mean, it couldn't say anything. Okay. For various values of x in the real numbers, explain what can the divergence test tell us about this infinite sum? And basically, our answer was when x is greater than or equal to 0, it says that it diverges.